All right, so this was 9.5. It says plot the point and then find 3 additional polar representations of the point using negative 2 pi is less than theta, which is less than 2 pi, and then find the rectangular coordinates for the point. So this means a couple of things. One is it's in between negative 2 pi and 2 pi, not including those, so you can't use those, okay? So your answer should be in that range. So be careful, you can't subtract it too much or add too much. So to plot the point initially, we would locate where 2 pi over 3 is. Your answer sheet, which is on the module and on like the weekly thing to print, I just added it there too. You'll see the polar grid, what it looks like. It doesn't have all the in-between lines like this one does, so hopefully you can get an idea of what to do. If you're at home, obviously you need to print it, or there's a lot of drawing to make it look like it if you don't have a printer at home this time, but you can get it done. Obviously, if you're in person, I'll have it printed for you. So then I'm going to go to 2 pi over 3, which is marked on that one. It's not on this one, but it is marked on that one. It's over here, okay? And I go out to the 4th ring, which is 1, 2, 3, 4, all the way out at the edge on this graph. But again, it depends. I think the rings go to 7 maybe on the one. Yeah, 7 on the one that's on the answer sheet. That's the coordinate point, right? Then it says find the additional representation. So you have 2 choices, and one is keep the r how it is. So the 4 would stay as a positive 4. And then add or subtract 2 pi. I can't add 2 pi. It's going to be too big, okay? But I can take 2 pi over 3 and subtract 2 pi, which would be 6 pi over 3, and I get negative 4 pi over 3. That's in between negative 2 pi and positive 2 pi. It's not writing, is it? Oh, no, it is. You just can't see it very well. That's not a good color, huh? Negative 4 pi over 3 would be one option. Then it says find 3. So I can't subtract the 2 pi again from that, which means I have to use the other option. Change the sign on the r. So because it started positive, I'll change it so it's negative. Add and subtract pi. So if I add pi to this, it would be 3 pi over 3, and I'd get 5 pi over 3, which is less than 2 pi, so I can use that one. And then for negative 4 again, keep it so it's a changed sign, and from the original, subtract pi, 3 pi over 3, negative pi over 3, which is also in that range, so I get to keep it. So here's the easy thing about these is if you've got a little bit of extra time, you should be able to plot all those additional points, and they should be the same point. So if I wanted to plot 4 and negative 4 pi over 3, negative 4 pi over 3 is going to go all the way around my circle clockwise till I hit where that 2 pi over 3 is, go out to 4, and it's the same point. If I go to negative 4 5 pi over 3, I would go to 5 pi over 3, which is down here, and I'm counting in the opposite direction away from the pole. So again, it would overlap on that coordinate point. And then negative pi over 3, which would be this first pi over 3 going clockwise, that 5 pi over 3, go across because it's a negative coordinate and it should be plotted in the same spot. So if for some reason those coordinate points do not line up, then obviously you did it wrong. They should all be able to be the same thing. The last thing here says, find the rectangular coordinates for the point. So I want to convert from polar to rectangular. And to do that, the x equals the r cosine theta, and the y equals r sine theta. So r is 4 times the cosine at 2 pi over 3. And the r is 4 again times the sine at 2 pi over 3. If you have your unit circle, which what I would strongly recommend, you would find 2 pi over 3 at this coordinate point here. The x and y there is negative 1/2 and root 3 over 2. Plug it in, I get 4 times negative 1/2, and then 4 times root 3 over 2. Simplify, negative 2 to root 3. So this question is open-ended. If you're taking it at home, obviously, if you're taking it in front of me, you'll just write that on a piece of paper. That part of that question is open-ended. The additional polar representations, switch the highlighter, this, and this will go on your answer sheet, which you'll see if you look at number 2 on the answer sheet. But then the conversion would go in Canvas. So it would typed in as negative, and I took it with parentheses or without. So like negative 2, comma, no spaces, for the love of God, 2 square root 3 would be entered like that. Or I took it negative 2 to SQRT 3, okay, without the parentheses. Just don't forget your signs. Questions on that one? Yep.
When do you make the r negative again?
If you're only adding and subtracting pi. So if you're doing an even multiple, think you're going completely around your circle. You're finding a coterminal angle, so you keep the r as it is. But if you're doing just pi, you're going halfway around your circle, so you have to change the direction of the r, which is why you change the sign. All right, this one says plot the given point in a rectangular coordinate. Plot the point given in a rectangular coordinates and then find two sets of polar coordinates for the point from 0 to positive 2 pi. So first of all, I'd be on an xy axis. This is going to be like negative 1.5, 1.4-ish. So I go 1, 2. I'd go left, and then I'd go down, and my coordinate point would be about there. And then it says find two sets of polar coordinates. So now I'm going from rectangular to polar. To do that, r squared equals x squared plus y squared. And tan of theta equals y over x. So r squared would equal negative square root 3 squared plus negative 1 squared. R squared would equal the square root of 3 squared, which is 3, plus 1. R squared would equal 4. R would equal 2. Then tan of theta is y over x. That goes back to being positive. Tan of theta would be a positive 1 over root 3, which gets rationalized to root 3 over 3. And then we want to inverse tangent that. And on your unit circle, if you've added on your tangents, you'll see that there's two places where tangent is positive root 3 over 3. It happens at positive pi over 6 and 7 pi over 6. And remember, only one of those is right, and we would pick which one? Why are you picking 7 pi over 6? Because it's in the third quadrant, which is where my coordinate point lies. Good. So the theta is 7 pi over 6. So my coordinate point, r theta, is 7 pi over 6. And if I were to graph it, if I overlaid a polar axis on top of this rectangular grid, you should get the same area. Bless you. Good?
Leave that for like 30 minutes.
Sure.
This question right here.
Yeah.
Can you go over to number 6?
Yeah. Oh, sorry. I saw your chat. Yes, I have the 7 screenshotted from Sai and the 6 from yours.
Okay. Thank you.
You're welcome. Okay, so it says this one is 7. This was Sai. This one was yours. Plot the point given in polar coordinates. So if it's a negative radius, we're going away from whatever that angle is. We have to find the angle first. Negative 5 pi over 4. Like if I just started from, I'll just pick the right one because I know that it's there. This would be, let's do it from a, should have just drawn regular lines, but you get the point. Negative 5 pi over 4 is negative, so it's going in this direction, and it goes past the horizontal, and it stops at the first pi over 4 after that. Okay, or again, you would look, this is 5 pi over 4, and then I would fold it in half to find where it overlaps. But either way, I should get the middle line in the second quadrant. That would be negative 5 pi over 4. Then if it was a positive 3, I would go on that ring, 1, 2, 3, but it's negative, which means I move in the opposite direction. So I'm actually moving towards the 7 pi over 4 angle 1, 2, 3 times, and then my coordinate point would go on that side. So this one had negative on both. Negative on the angle takes you in the opposite direction, and then negative on the radius moves you away from that angle. Then it said find 3 additional polar representations of the same point. So if I wanted to keep the negative 3, then I have to take negative 5 pi over 4. I can't subtract 2 pi from it. It would be too small, but I can add 2 pi or 8 pi over 4. And I get 3 pi over 4, so that's one of the polar representations. I can't add 2 pi to that again, it's too big, which means I now have to switch to the other option of change the sign on the r. It started negative, so I'll change it to positive. and then take my original, that negative 5 pi over 4. I can't subtract pi this time, so I have to add it. I'd add 4 pi over 4, and I get negative pi over 4. Because that is also negative, I can actually find the coterminal to that one. So I can't add pi to that, but I can add 2 pi to that, because that would make it coterminal. And then keep the r as positive 3, and I'd get 7 pi over 4. Think about your graph. If I went 3 pi over 4, let me change the colors. If I went 3 pi over 4, it's here. Negative 3 would put it on the opposite direction, so that one works. Negative pi over 4 is the same thing as 7 pi over 4. The 3 is there. And 7 pi over 4, 3 is also the same coordinate point. And they're both between negative 2 pi and positive 2 pi.
When you're doing the method, like folding in half, are you doing it on the x-axis or the y-axis?
Folding in half, you do on the x-axis, top to bottom.
Okay.
Yeah. Like a hamburger. Okay, then this is 6. Again, plot the coordinate point and then find the additional representations. So plotting for square root 3 and negative 4, we're going to say that this is, again, like a 1 point. It's actually like, I don't even know. 1.3, 1.7 actually, I think is, yeah, 1.7 if we wanted to be a little bit more accurate. But then you'd have to multiply that times 4, so you're at 6.9 and negative 4. So just a total approximation there. So I know I'd move left just shy of 7 and down to 4, and that would be the coordinate point.
Wait, but it's not negative 6.5.
Move the other direction. Thank you. Move right 1, 2, 3, 4, 5, 6, 7, and then negative 4. And that would be the coordinate point on the rectangular coordinate grid. And then to convert it, this is in rectangular, we want to go to polar. So I would do x squared plus y squared. That's going to give the r squared. So square root of 4 root 3 squared plus negative 4 squared. This is 16 times 3, 48. And then minus or plus 16 square root of 64, which is 8. So that's your r. And then tan of theta would equal y, negative 4 over 4 root 3. And I get negative 1 over root 3, which would have gotten rationalized to negative root 3 over 3. So then I'm using my unit circle to find where on the unit circle tan is negative root 3 over 3. That happens at 5 pi over 6 and 11 pi over 6. So I come back to the graphed point, which is in the 4th quadrant, and I know to pick the 11 pi over 6. So that's one of the coordinate points that I can use between 0 and 2 pi. So this time the restriction is different. If I want to use the other one, I can't subtract 2 pi because then it's going to be negative, and it's saying don't let it be negative. I can't add 2 pi, which means you have to use the other method. Change the sign on the radius, and then add or subtract pi. If I add pi, it's too big. If I subtract pi, or 6 pi over 6, I get the 5 pi over 6, which is the other angle that works.
Miss Wonder, can you scroll up a little bit?
Like that?
Yeah.
Okay.
Because I thought we had to graph it in rectangular when it's in rectangular and then turn it.
Yeah.
Oh.
Well, I mean, it won't really, it doesn't really matter if you're doing it by hand. It doesn't really matter. But if you're given a coordinate grid, you're going to get either given the rectangular or you're going to get given the polar. So you would do it in whichever grid you have.
How many graphs are on the quiz?
The parametric. Yep, parametric with the t-chart, and then the polar with the points. Everybody good? Okay, so the quiz tomorrow is covering 9.4 and 9.5. There's no calculators for this one. And if you're at home, make sure you print that answer sheet. So again, I put it on the module and I put it on the weekly plan under today, so you remember to do it. There's actually extra boxes on there that we won't use, but it doesn't matter. It's not like they're at the bottom of the page. It's not like you're saving a page by not using it. The quiz is only 6 questions. I took off the calculator part so we don't use the calculator. Sorry, yesterday I rolled my ankle, so all my friends are asking me if I'm okay. It's the most embarrassing thing on the planet. So 6 questions. Bless you. Okay. So from 9.3, there was 3 different kinds. Sorry, from 9.4, there's 3 different kinds. In 9.5, there was 3 different. In 9.4, there's your T-chart. And then the graph. Remember, you have to do your orientation arrows on that. So there's 2 questions like that on the review. Fill in you'll obviously see your T-chart on your answer sheet. It's pretty straightforward. You'll fill in the T-chart. I will give you the range of the points to do on the test, on the quiz, so that it's the same. And then you'll plot your points and then make sure that you add the arrows. So don't forget your arrows for your parametric graph. Then it was what came next? Eliminating the parameter. Which means get rid of the t. So we solve one equation for t, and then substitute it into the other equation. And your answer for that is going to be a y equals. And then came the finding 2 equations with t. So one equation is going to have a t, one is not. You're going to solve the one that does have the t. For whatever the other variable is. So if it's the x that has the t or the y that has the t, most of the time it's been the x, but it could be either. You're going to solve that for that variable, solve for the x or for the y, and then plug it in to the second equation. And this time your answer is going to be an x equals, and it has to have t, and a y equals, and it has to have t. So in the second kind of question, you're eliminating the parameter to get an approximation of your graph. In the third kind of question, you're bringing the parameter in.
Solve one equation for t.
Yeah. Well, wait, which one? The last one?
The second.
The eliminate. Yeah, solve for. No, thank you.
Are you okay? Is your ankle?
Yeah, I'm fine. Yeah. And it was super fun. We were relaying, racing against our children up a water slide, and it got too muddy. Just rolled it right in the mud. I still finished, but it was painful. And they still whooped our butts all 3 times. It was more entertaining to watch grown adults try to climb a huge water slide and miss the rope and go boom, 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 down the steps. That was the best part. Not me, but someone else.
And those hit because you're just like,
Oh, yeah, yeah.
yeah.
And the kids chanting, fall, fall, fall. I'm like, excuse me, we did not do that to you. Okay, and then 9.5 is what we just literally did on the warm-up. So you're going to get to plot the polar point. And find additional, if I could spell additional, that would be helpful. Additional points. And then converting from polar rectangular to polar, and polar to rectangular. That's it. So rectangular to polar, you do r squared equals x squared plus y squared, and tan of theta equals y over x. And for polar to rectangular, x equals r cosine theta, and y equals r sine theta. So we just talked about this, but remember, additional points, you either keep the r and then add and subtract even multiples of pi, like 2 pi, or you change the r and you add and subtract odd multiples of pi. And those you can check, make sure that when you plot them, they're the same. In addition to this, I wouldn't really say you need too much more, but you definitely want the unit circle with your tangents added on. And I would write them around the whole circle this time. The 3 pi over 4, if you look at your unit circle, 3 pi over 4 is in that top left corner, like this line in here, okay? And then 2 means keep it positive, so literally go 1, 2, that coordinate point should be there.
Mr. Smagic?
Yeah.
It was for the 9.4.
Oh, Lord.